In this video, we're going to talk through Objective 4, Mastering Logarithmic Properties. So, there's three properties I want to talk about throughout this video, and in this instance, as I talk about them, these properties are going to expand logarithmic functions, but they work hand in hand. You can use them to expand functions or condense them back to their original form. So to begin, the first one is the product property. If you notice, I have a log base x of a times b. Alright, so with the product property turns into addition. Alright, keep that in mind. It's similar to the exponent rules. Base times base, you add the powers. Log of a times b, you add the outputs type thing. So if I'm going to expand this using this property, I'm going to write, if I notice I have two outputs, an A and a B multiplying on each other, so that tells me I'm going to have two logs, alright? If there is three outputs, an A times a B times a C, for instance, then I would have three logs written out, but it's just two in this case, so I write log base x of A plus log base x of B, and I am done. That is the product property. And you can use it to expand and then also condense. It's the same process. If you notice, if you were given this, and it's log base x of a plus log base x of b, and they're telling you to use the properties to condense them, it would go back to its original form. I would write just one log. The goal when you condense is just to have one log base x of a times b. And I know they're multiplying because they're adding here. It goes hand in hand. Alright, let's move on to the quotient property. Hopefully you remember from exponent rules, base divided by base, you subtract. So log base x of a divided by b, you subtract the outputs. So again, I have two outputs, an a and a b. I'm going to have two logarithms, alright? But that just means then log base x of a minus log base x of b. And if you were given log base x of a minus log base x of b, and they told you to condense it using these properties, you should be able to know that a is going to be divided by b. Alright, so if I write it in the condensed form, I have one log again, log base a. You take the first piece, put it as the numerator, over the second piece, the denominator, just like that. Alright, so if that first piece instead of a was like x minus 1, it would be log base x of x minus 1 over b. Whatever that first piece is becomes the numerator. So if you notice, it goes back to its original form. And then finally, the power property. It's a little bit different than exponent rules. The power in this case, if I read this logarithm, is log base b of a raised to the x. So the x is the power. Alright? So the power property goes in front. I'm going to write. So this is technically the condensed form, log base b of a raised to the x. The expanded form is log base b of a, but that x gets drawn out front, just like that, okay? And so you'll have to notice with the power property, you just have to recognize that the condensed format, the one that was given to me, log base b of a raised to the x, the power is in its place, it's up above the output, but the expanded form, the power exists in front of the logarithm. So if I want to take it back to condensed form, I just have to recognize that log base b of a goes back to its original position of x. So let's try a couple where we're just going to, I'm going to expand, I'm going to try two of them. Alright, then I'll have you try two on your own, okay? Let's treat, just for this instance, if you notice like this log base 3 of 5x here, let's treat that as one thing, okay? So I'm not going to have a log base 3 of 5, a log base 3 of x squared and y squared. I'm going to have just one thing. So I'm going to do C as an example, and I'll do D as an example, and I'll have you try A and B. So if I do C here, and it says to expand the following logarithmic expressions using the properties of logs, I know that I have one output, two outputs. So that should tell me that I'm going to have two logarithmic functions when I expand this. And I know that 5x squared is multiplying y cubed, and so I know that I'm going to use the product property, but if you notice also, they both have powers, and so I'm also going to use the power property. So please pay attention of how I do this, okay? I have log base 3 of 5x, and that power of 2 goes up front of that logarithm, all right? Then I add, because of multiplication, log base 3 of y, and the power of 3 goes out front of that logarithm. And I'm done. I have expanded the logarithms, all right? So go ahead and pause the video and try example A on your own, noticing that there's 3 outputs, x, y, and z. And if you also recognize there's no base written, but remember that's whenever there's no base, you can assume it's log base 10. Okay, so go ahead and pause the video and try A on your own. All right, at this point you should have paused the video. I'm going to show you my thought process I go through, so please check your work with mine. I have 3 logs, a log base 10. I can write 10, I don't have to. I'm just going to show you that it is 10, so I'll write it. Log base 10 of x plus log base 10 of y plus log base 10 of z. Pretty straightforward, pretty easy. And the only property that was being used there was multiplication, which turns to addition when I expand. All right, one more example, then I'll move on to condensing before the video ends. All right, if I do example D, first thing I notice is that it's dividing. So I'm going to use, instead of the product property, now I'm going to use the quotient property, which turns to subtract. So, and I notice that there is a numerator and a denominator here. So I'll have 1 output, 2 outputs. I have 2 total outputs, so that means I have to have 2 logarithms, all right? And it's log base 10 again because it isn't notified otherwise. So I'm going to write log base 10 of the first output, 3x, minus, because it's division, log base 10 of 2. All right, so at this point, please pause the video and try example B on your own. So at this point, you should have paused the video. I have a log base 2 of 4x divided by y, and so I know that I'm going to have 2 logarithms, log base 2 of the numerator, subtracting log base 2 of the denominator, and I am done. So that's expanding. Let's move and find one that is, because there isn't one on this sheet before. No, I want to condense one with you all as well. So if you notice in the practice, now these examples say condense the following logarithmic expressions using the properties of logs. So I'm going to do one, let's see here, that has that has powers as well. So I'm going to do F, and I'll have you do E on your own within this video before you try the practice on your own. And if you notice, like, remember that 3x and that 2y is its own output. Those aren't 2 different outputs. Just consider that. So if I'm going to do F, I want to do this one to show you that there's addition and subtraction going on here. Okay, so whenever that's the case, I'm going to do the addition first, and these 2 pieces of addition will become my numerator, and then it's going to subtract the output of z with my denominator. All right, so this x and this y with its powers will become my numerator. And if you notice, remember, the first step in condensing is to realize we only are going to have 1 log, all right? We have 3 logs, which means we have 3 outputs, but it condenses down to 1 log. In this case, they don't have a base, so I can write base 10 of, I have an x. And please remember, this x has that 3, and when I condense it, that 3 has to come back into the powers. So x to the 3rd times y, that 2 has to come back into the powers when I condense. Y squared, so that addition, remember, addition turns back into multiplication when you condense it. That turns into multiplication in my numerator. Now, my denominator, because of this subtraction sign, I also know that I need to divide the last logarithm. And so that denominator becomes z, but again, that 5 goes back to the powers when I condense it. z to the 5th. And that is how you would condense that. And condensing is very important because you're going to use that skill to solve logarithmic equations later. So go ahead and pause the video and try example or try E on your own. All right. At this point, you should have paused the video. I'm going to show you my thought process, so please check your work with mine. A couple things I noticed with this, that there are powers involved. Each logarithm has a power, and it's addition, so I remember that addition turns back to multiplication. I'll have one logarithm, log base 3. Not the numerator, there's no numerator denominator, it's just addition, so it's going to be multiplication. It's going to be x raised to the 1/2, remember that 1/2 has to go back in the powers when you condense it, times y raised to the 3rd. And that is the condensed form of that, those two logs. So, if you didn't get, when you tried these problems on your own, if you didn't get something that looks like mine, please raise your hand so I can check your work. But that is the properties of logs. Thank you for watching.